this lesson, you are going to look at transformation of functions. So functions we've dealt with, but in this case, I've drawn, not necessarily, I've made something that looks like a function on a system of axes. So the transformation that you have to look at a translation, which is just generally shifting the graph. Either you shift the graph horizontally or you shift it vertically, up or down. The next one would be reflection. If we have to reflect this either on the y-axis, so we'll reflect this along the y-axis like that, or we'll reflect it on the x-axis, we'll reflect it like this. The other one will be stretch, horizontal or vertical stretch. When you stretch horizontally, means you are stretching it like so, or when you stretch it vertically, you will be stretching it like that. Then there will be compression. Compression is when you press a thing, right? So you press it this way, making it smaller, or you'll press it like that, compression. So those are the types of transformations. It's translation, which is just shift, the reflection, the stretch, and compression. You've done it, but it's just that we've got to look at it a little bit more. Now, let's look at an example. Let's say you are given a sketch like this one, y is equal to f of x. Now they say you must transform it by vertical shift of 2 units up. It means that this graph of ours must be moved 2 units up. So I'll move it 2 units up, so which means that my graph will now be, say, there. The new graph would be there. It has moved 2 units up. Okay, so we call that a vertical shift of 2 units up. So the new equation, if this was y is equal to f of x, so the new equation now will be y is equal to the f of x is the same graph, but I've moved it 2 units up, then I say plus a 2. Let's say, for instance, the graph was given as the equation as y is equal to x squared. So if I move it 2 units up, it becomes y is equal to x squared, then a plus a 2. Let's look at this one. Y is equal to f of x is drawn like that. They say there must be a vertical shift of 2 units down, meaning that this graph must be drawn down 2 units. So if I draw it down, it will be down there. So 2 units down, so this one will be at a minus 2. If that one is 0 there, that one goes to 2 there. So it minus to 2 units down, and therefore the new equation of this graph now is y is equal to, it was the same equation which was f of x, but was shifted 2 units down, so minus 2. So if the equation was y is equal to x squared, so the new equation will be y is equal to x squared, you just say minus 2, 2 units down. Let's look at one that may be complicated. They can give you an exam. They say write down the equation formed if the graph of y is equal to blah 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 is shifted 7 units down. So this whole thing is shifted 7 units down, so it means that the new equation will be what? Y is equal to this whole thing, the minus 3 into x minus 4 all squared plus 5, then shifted 7 units down, so say minus 7. Obviously, you can simplify the plus 5 minus 7, and then you can get an answer of minus 3 into x minus 4 all squared. The plus 5 minus 7 would be a minus 2. Let's look at another one. There is a graph again drawn like this. Now, they say this is y is equal to f of x. This must have a horizontal shift of 2 units to the right. So draw this graph. You shift it horizontally 2 units to the right, so it means that the graph will be now on the side, like that. So now I've got 2 units to the right. It went 2 units to the right. So in this case, when that happens, how do you write the new equation? So it was the same equation, but because I'm affecting the x, if you affect the x, you must always put things in bracket. So therefore now this is y is equal to f of x. So it must be inside the bracket now. So inside the bracket, remember, this is plus 2. So it moved 2 units to the right. What do we write inside the bracket? We don't write plus 2, we write minus 2. We write minus 2 because if we solve x minus 2, we will get a positive 2. So that's how we write it. Okay, now let's look if it was given like this. Remember we said if we are moving along the x-axis, we put it in bracket. So this one will be y is equal to, it must be in bracket with a square. So it will be x shifted 2 units to the right, but we say minus 2. Now let's look at this one. It's a horizontal shift of 2 units to the left. So this graph is taking 2 units to the left. So it means that the graph will be like this to minus 2 on this side. So if there's minus 2, so the new equation now will be y is equal to, it was f of x, it will be f of in bracket because I'm moving horizontally, so therefore it will be x, but this is minus 2. If it's inside bracket, we say a plus a 2. All right, now let's look at it. If it was given like this, so I will say y is equal to, I'll put in bracket squared, but it was moved to the left, but in bracket I will say x plus a 2. Now, let's say they write it like this. Write down the equation formed if the graph of this is shifted 7 units to the left. Right? 7 to the left, it means that horizontally. In brackets, with the x, we put it in brackets. And then we put a 7. So this will be y is equal to 5 over. Note that this is a bracket line or something. So there is an x. In the bracket, this must be in brackets, so it's be an x, then 7 units to the left, so 7 to the left, then I say a plus a 7, then there is that plus 2 over there, and then plus a 3, then there is an x, is x plus 7, then minus a 4. So you can simplify this if you like. If you like to simplify this, so it becomes a 5 over this x plus 7 plus 2 will be an x plus a 9, and this will be a plus a 3 into x plus 7. We can leave it like that. It makes things simpler for us to read. Okay, now let's look at another one. Say you've got this one here, another example here. So you've got a graph y is equal to f of x. It's written like that. They say you've got to reflect this one here about the y-axis. Now I've got to reflect it about the y-axis. I'm holding the y-axis, I turn it around like that. Okay, so I turn it like that. So it means that now if I hold here, so this is holding here. So if I turn it around here, it means that this piece will be like this and like that. So this will be now a minus 2 like that. Okay, so I just turned it like this. Okay, so if I do that, so the new equation now, if you turn like that, note the positive x became a negative x. In fact, what we are doing here, we are changing the sign of x. So when you reflect about the y-axis, you just change the sign of x. So therefore, the new equation, if that was y is equal to f of x, it becomes y is equal to f of, change the sign of x. So it's minus x. Because that was an x, now it becomes a minus x. Let's say the equation was given like this. So it's y is equal to x, bracket x minus 2 all squared. So just change the sign of x. So it's a minus x, a minus 2, then squared. Done. The next one. Let's say this was an equation. Now they say in this one here, it's a reflection about the x-axis. In that one was about the y-axis. We're holding the y-axis, so we're turning like this. Now about the x-axis, now we are here, we are turning around like this. So which means that now when you are turning like this, so this graph of ours will be like this now. Sorry. It will be like this. Because I'm holding here, so I'm holding here, then boom. So then it means that this piece here will be a minus 4 down here, and then so this would be like y is turned upside down. So if it's turned upside down like this, therefore the graph won't be like they're having an equation like this. What am I doing? Look at the y value there is positive y. Now the y value here is minus 4. So when you reflect about the x-axis, we just change the sign of y. So we are changing the sign of y. Y was a positive f of x, but now I must change the sign of y. Y was this, so I must change the sign of this so it becomes a negative there in front. Okay, now let's look at the equation here. Let's say here, write down the equation formed if this graph here is reflected about the x-axis. Also, let's look at that example here. Y is equals to this thing here. So reflecting about the x-axis, just change the sign in front. So this is y is equals to minus, and then you've got an x minus 2, which is squared. Now, here is this one. Write down the equation formed if this graph here is reflected about the x-axis. So what do we do? Y is this. So change the sign of this. So therefore, the new equation will now be y is equal to the change of all of this is minus the whole of this thing here, which is 5 over x plus 2, then plus a 3x minus 4. So you change the whole of this thing. But of course, you can simplify and do your distribution. So the minus will multiply this, a minus will multiply this, a minus will multiply this. So you could have written maybe a minus 5 over the x plus 2, that and that is minus 3x, and then that and that is x there, and then plus a 4. Now let's look at another one. One more juicy one. They say here, here's an example. We've got this line drawn. They say, what will the coordinates of A be under the transformation of f? There is A there. So A is a 0.2 is to minus 3. If they say you've got to transform this, so it's now this is f of x. If I say f of x plus 2, what happens to the graph? This means that the graph is moving 2 units up, isn't it? So this graph will move 2 units up. From there, it will move 1, 2. So the new point will be over there, and then the x value will still be this one, but the y value will be a minus 3. So the new point for A will be a 2 is to that number there, which is minus 1. Let's look at another one. Y is equal to f of x plus 3. In this case, it's a horizontal shift because it's got this is inside the brackets. We are moving sideways. But this is x plus 3. So this thing will be moved to which side? The opposite direction, because when you solve for x, you get a minus 3. So I'll move this point 3 units to the left. So I'll say 1, 2, 3. So the new point will be over here. And what are the coordinates of here? Is minus 1 is to minus 3. So the new coordinates of A now will be minus 1 is to minus 3. Next, what about this one? Y is equals to f of a negative x. What are we doing? We are changing the sign of x because that was x. So now we're changing the sign of x. So I'll just change the sign of x. So what are the new coordinates of A? So A is change the sign of x. It's minus 2 is to minus 3. Let's look at the next one. Y is equal to a negative f of x. So what am I doing? I'm changing the sign of y. So I'm changing the sign of y. So therefore the new point is A is to change the sign of y only. Is 2 is to a positive 3. That's it. It's very easy. So you can try your own problems here, which are from your Grade 11 Siyavula Maths textbook, Chapter 5, the quadratic functions, Exercise 5.6, number 4, on the exponential function, Exercise 5.19, number 1 only.